Hello everyone, so welcome to my YouTube channel. So guys, in today's video we are going to see we have completed with haloalkenes and haloarenes. We had completed with alcohol, phenols and ethers. So in this video we are going to complete aldehydes, ketones and carboxylic acid. So let's start. Before starting, I will tell you one thing about aldehydes, ketones and carboxylic acid, like how we have studied in haloalkenes and haloarenes, then how we studied in alcohol, phenols and ethers. There we can relate every, what you can say, every reaction, every mechanism, like yes, this thing, how it will break from one reactant and how the things will break from another reactant and how the both reactant will combine and how we are going to get the product. So what I told, like in the last video only, in alcohol, phenols and ethers, I told that till haloalkenes, haloarenes and alcohol, phenols and ethers, 90 to 95% of the reaction we understand and then we have written, right? We understand the mechanism, how this thing break down and how that other thing get bounded and how they are going to produce the product. So we have understand the concept and then we had written the reaction. Okay, but in that only I told you one thing, that very few reactions are there which you have to by heart. Okay, so in aldehydes, ketones and carboxylic acid we are going to get the few types of reactions which you have to by heart, but others are also there in this chapter only which we can understand through concept and we can do it. Okay, so organic chemistry, what will happen guys, the two things will happen. First thing is maximum part. If you will see the whole organic chemistry, so maximum reaction and its mechanism we can understand and then we can write. Okay, very few, 15-20% of the reaction and its mechanism are there which you have to by heart. Okay, so let's see. So here aldehydes and ketones, and carboxylic acid. Remember the thing, few reactions are there which you have to by heart. How you will by heart? You will write 4 times, 5 times you will write, then you will understand and you will by heart that reaction. Okay, chalo bhaiya. See aldehydes, what we know, aldehydes, ketones and carboxylic acid, all we know that they have a common is the carboxylic group. They have a carboxyl group, C double bond O. Okay, so aldehyde, ketones and carboxylic acid. What is aldehyde? With C double bond O we have H one side and other side we have a chain, so this is aldehyde. Keton with C double bond O, both side we have a chain. Chain means what? Alkyl group. Chain means any alkyl group, methyl, ethyl, propyl, butyl, that will come under the chain. Okay, or any other, you can make carbon any other, like you can a branch of chain or the compound, any other which is attached. We don't care about that, what is attached to the main group and all. Okay, just we have to understand that if C double bond O is attached with one H and other side is chain, whatever the chain it will be, so that is a aldehyde, because this indicates the aldehyde, CHO, aldehyde. Then keton with C double bond O, we both side we have a chain, that's called a keton. Carboxylic acid with C double bond O, one side we have OH, that alcohol ka OH, and other side we have a chain. So what will happen? This will become COOH. So it will become a carboxylic acid. Okay. Next we will see the preparation of aldehyde and ketone. So guys, very important thing. Remember the name of the in this aldehydes, ketones and carboxylic acid. Remember the name of the reaction which produce what. Okay, so here preparation of aldehyde. So remember the name of the reaction which provides the which gives the aldehyde. Remember the name of the reaction which gives the aldehyde. So see, this is aldehyde, CHO aldehyde. This is aldehyde. Okay, then this is the aldehyde, means benzaldehyde is also aldehyde, CHO aldehyde. Okay, so first we will see here. Dekho. Rosenmund reduction, Stephan reaction, Gattermann-Koch reaction, Etard reaction, ozonolysis, this all gives final product is aldehyde. So what we will get to know that we have to produce aldehyde. So it will become easy for you. Okay, Rosenmund, Stephan, Gattermann-Koch reaction, then Etard reaction, ozonolysis. This all the 5 reaction will give you aldehyde. Okay. So remember this thing, very important. Rosenman, Stephan, Gatterman, Koch reaction, Itard reaction, ozonolysis. This all 5 reaction gives a final product as aldehyde. So देखो भैया, Rosenman, what will happen? RC double bond O. This RC double bond O is connected with Cl. Guys, see, whenever I will talk about X means not yours. Whenever I will talk about X means halogen group. So whenever I will talk about X means halogen group. In halogen group we have a fluorine, chlorine, bromine, iodine. So guys, fluorine and iodine we are not going to take. We'll take only chlorine and bromine. The reason is fluorine is a very small element. Over a small element, if we have a large electron density, what will happen? It will become highly reactive. Okay. And iodine, what will happen? Bolo bhaiya, it will become less reactive. Like if iodine size is what? Bigger size. If bigger size, if you give the electron density, it will occupy and it will become like a stable type. Little bit stable. It's not the much stable. Little bit stable it will follow. So that's why fluorine and iodine we will not take. We will take chlorine and bromine in the halogen. Okay. So what is Rosenman reduction? Rosenman reduction will take C double bond O connected with R, C double bond O connected with R, and then connected with either chlorine or bromine. So what will happen? This Rosenman reduction is H2. H2 means what? Addition of hydrogen. The addition of hydrogen means what? Hydrogenation. The Rosenman reaction shows hydrogenation process. Okay. Because addition of hydrogen. The Rosenman reaction, what will happen? So these are the reaction what you have to understand. Rosenman reaction. Okay. Rosenman reaction is C double bond O connected with R and this connected with Cl undergoes hydrogenation, means addition of hydrogen H2. So a simple thing. What? देखो भैया, simple. What we know here? C double bond O connected with R connected with Cl, it undergoes hydrogenation H2. Okay, so in presence of PD, palladium, barium sulfate. So guys, see what will happen. We know that this is what Rosenman reaction. Rosenman reaction, what the final product it will give? Aldehyde. Aldehyde means what will happen? See here guys, what will happen here? Oh bhaiya bolo. See this, what will happen? We are getting aldehyde. RC double bond O. Here connected H2, 2H. So one H will connect here and it will break this. Why? What will happen? Another H will connect with Cl. It will become HCl. So like that you will understand that okay, we are going to get aldehyde. Now so aldehyde, how we are going to get? With C double bond O, I will join one H, means we are breaking this bond, and we have a 2 hydrogen. One hydrogen will join here, so it will become aldehyde. Other hydrogen with Cl, HCl. So like this you have to understand, it will become very easy for you to solve. Okay. So Rosenman reaction, what it will show? It will give aldehyde as final product. Rosenman reaction, it will give aldehyde as final product. So what will happen? C double bond O connected with R connected with Cl and it undergoes hydrogenation, addition of hydrogen H2 in what the catalyst? Palladium, barium sulfate, PD, BaSO4. So what we will get? We will get aldehyde. So aldehyde means, see this, one H will get 2H. Now one H will get add here, another H will go with Cl, that will become HCl. Next, Stephan reaction. Stephan reaction will also give aldehyde as product. The Stephan reaction, see, is a cyanide group we will take. RC triple bond N. RC triple bond N, it undergoes SnCl2 plus HCl. It undergoes SnCl2 plus HCl. So what will happen? This bond will break. It will break the one bond. Why? This hydrogen will go here, it will break the one bond. So what will happen? One bond will break, it will become NH. One hydrogen will go and connect here, it will become CH, double bond. Okay. Then RCH double bond NH undergoes hydrolysis process, H3O plus. H3O plus, what will happen? We know that Stephan final reaction is what? Yes, aldehyde. So aldehyde means RCHO. O group will come here and then remaining ammonia will be here, NH3. Okay. Now Gatterman-Koch reaction. Gatterman-Koch reaction means from benzene we will make benzaldehyde. Gattermann-Koch reaction is from what? From benzene we will make benzaldehyde. The Gattermann-Koch reaction, this is the benzene. It goes with CO plus HCl in presence of anhydrous aluminum chloride or CuCl. We will get aldehyde, means benzaldehyde. Now Itard reaction is methyl benzene will give benzaldehyde. Methyl benzene means what? Toluene. Toluene will give benzaldehyde. Okay, this is easy guys, this is easy. Gattermann-Koch reaction is what? Benzene will give benzaldehyde. Benzene in presence means react with CO plus HCl in presence of anhydrous aluminum chloride or CuCl, it will give benzaldehyde. Itard reaction is what? Itard reaction, toluene will give the benzaldehyde. Toluene will give the benzaldehyde. Toluene means with benzene CH3 it will give benzaldehyde. CrO2Cl2 with CS2, and then we'll do the hydrolysis, will give the benzaldehyde. So remember the thing is what? All these 5 reaction, Rosenman reaction, Stephan reaction, Gattermann-Koch reaction, Itard reaction, ozonolysis, all the final product is aldehyde. Okay, so what we know, Gattermann-Koch reaction, from benzene we will get benzaldehyde. Itard reaction, from toluene we will get the benzaldehyde. Okay, before that, Rosenman, C double bond O connected with R connected with Cl undergoes hydrogenation, so we will get aldehyde. R C double bond O, with that H will connect and one H will go with Cl, HCl. Now Stephan reaction is a cyanide group we will take. R C triple bond N, what will happen? This triple bond will break, the one bond will break to NH and here CH. RCH double bond NH. Then it will undergo H3O plus. So what we will get? Obviously we will get the aldehyde, so RCHO and then ammonia group. That's it. Now ozonolysis. Ozonolysis means what? We will take the ethene. We will take ethene. Ethene will undergo ozonolysis. Ozonolysis means what? O3. Ozonolysis means O3. Ethene will undergo ethane will undergo ozonolysis process. So ethene react with O3 in presence of CHCl3. So देखो simple guys, what will happen? देखो CH2 CH2, correct. Now 3 oxygen will add, 1 oxygen here with carbon, 1 oxygen here with correct, 1 oxygen here with carbon, 1 oxygen here with carbon, and this in the common. So see here, 1 oxygen, 2 oxygen, 3. It's make like a heart structure, not heart. Okay, so this. So ozonolysis means what will happen? Ethene react with O3. Ozonolysis means O3. Ethene react with O3. So what will happen? With all this double bond will break. With 1 carbon will get 1 oxygen, another carbon, other oxygen, and then this oxygen is for common for both carbon, and this will connect. So after that what will happen? We have to break this, because what we will get the final product. Yes, final product we want is aldehyde. So let's break this. If you will break this, what we will get guys here? HCHO. Here also HCHO plus in presence of H2O Zn. So next is ZnO. So HCHO means what? Aldehyde. That's it. Now 1 degree alcohol. Guys, we know 1 degree alcohol, if we will do with copper in presence of 573 Kelvin heat, we will get a aldehyde. 1 degree alcohol will give aldehyde, 2 degree alcohol will give ketone. We already studied this. 1 degree alcohol will give aldehyde, 2 degree alcohol will give ketone. Now see, from alkene means what? Triple bond, C triple bond C. So what we will do? We will do plus H2O in presence of HgSO4, H2SO4. So what we will get? CH3, CH2OH. So these are the reactions what I told. Few reactions you have to write and by heart. Okay, see these are not by hearting. You will understand. From toluene you will get benzaldehyde. This also not by hearting. From benzene you will get the benzaldehyde. You also understand this. The Stephan reaction is you can write and you can by heart it. Okay, not the Rosenman reaction. Now when you will come here, 1 degree alcohol is aldehyde, 2 degree alcohol is ketone. No need of by hearting here. And this also, when we will see for ozonolysis means what will happen? Ethene react with O3. So with every carbon, the 2 of 1 each carbon, each oxygen will connect, and with this carbon the common oxygen will connect. Then we will break here, we will break this part. So what will happen? HCHO will get from this side, SCHO will get from this side, and then with Zn this O will go ZnO. So this is a simple thing, no need of by hearting. Here you can by heart is only a Stefan reaction. And next, coming to here from alkene, you have to by heart this. From alkene what will happen? Alkene reacts with H2O in presence of HgSO4, H2SO4. What you will get? You will get alcohol. CH3 CH2 means all this triple bond will break into single bond. CH3 CH2 OH. For this CH3, then CH2, then here OH. Okay. Now next is what? Next is from benzene. See, benzene react with the same C double bond O connected with RCl in presence of anhydrous aluminum chloride. So with benzene what we will get? This group. Because see, we know that chlorine will break from here. Chlorine will break from here and it will make HCl. Now what is remaining group? COR. COR will get connect here. COR. So what will happen? COR will get connect here. That's it. So you have to remember from alkene and then this Stefan reaction. Other than that, guys, I don't think so you have to remember. If you understand easily, it is easy. Okay, from benzene what will? From benzene we will connect C double bond O R Cl in presence of anhydrous aluminum chloride. The chlorine will break from here. There is a one group that's called halogen group. The chlorine will break here and it will make HCl, and this what will happen? Another group COR. It will get connect over benzene COR. That's it. So guys, what will happen? Two reactions you have to by heart. Others I have explained you through the process. I hope you understand this process, how we are going to make this. Okay. Next is physical properties of aldehydes and ketones, then physical properties of carboxylic acid. Guys, please go through the NCERT textbook and read the physical properties of aldehydes and ketones and read the physical properties of carboxylic acid from NCERT textbook, and this two topic will be done. Next is nucleophilic addition reaction. So nucleophile will attack. So nucleophilic addition reaction and addition elimination reaction. So what will happen? Nucleophilic addition reaction and addition elimination reaction, both where we will take carbonyl group C double bond O, C double bond O. So nucleophilic means we will take the nucleophile, and then what will happen? See, this bond will break here. So oxygen is more electronegative, so this bond will go towards the oxygen. Oxygen will become minus, carbon will become plus. So this is the nucleophile which is minus. It will have, where it will attack? It will attack the carbon, the plus. So what will happen? This is a slow process. So carbon with that nucleophile will attach, and this O minus. So O minus is there. What will happen? O minus, we will write H plus, which is a fast reaction. H plus. The H plus will attack the O minus. It will become, we will get the alcohol. That's it. Now addition elimination reaction, again we will take the carbonyl group reacting with NH3. This is what? NH3 ammonia. So how I will break the NH3? Will break the NH3 like NH2 and then H. So what will happen here? NH will attach here, C double bond O. Okay, fine, sorry guys, sorry. NH3 will break like this, sorry. NH3 will break like this, H2 and NH, H2 and NH. Okay, so what will happen here? H2 and NH. So NH will here, this NH will attach with, means NH will come in place of O, and O will go here. Okay, so addition elimination reaction means what? Will eliminate the oxygen, we will add the NH. Will eliminate the oxygen, will add the NH. So C double bond O, what will happen? Oxygen will get eliminated from here and NH will add. The reason behind is we have already H2. See, this is NH3 ammonia. How the ammonia we are breaking? We are breaking ammonia like this, NH and H2. So H2 will react with oxygen and it will make H2O, water. So remaining is what? Remaining is NH. NH will get add in place of O. So see this, C double bond NH. Done. Now next is chemical properties. See, chemical properties, we know that 1 degree alcohol, if we will oxidize, see in the last chapter we already studied, what we studied, 1 degree alcohol, right? 1 degree alcohol, if we will oxidize the 1 degree alcohol, we will get aldehyde. Yes, the oxidation ulta process is what? Reduction. So 1 degree, see, we know that 1 degree alcohol, if we will oxidize, we will get aldehyde. But same if you will go opposite, from aldehyde to alcohol, means what? Reduction. Correct. See, 1 degree alcohol, you oxidize, you will get aldehyde. Now come opposite. From aldehyde, now we have to get 1 degree alcohol. So from 1 degree alcohol to aldehyde, we are oxidizing. So from aldehyde to 1 degree alcohol, we have to do reduction. Okay, so chemical properties, aldehyde to 1 degree alcohol is reduction. Now same, from 2 degree alcohol, we will get 2 degree alcohol. If we will oxidize, we will get ketone. But if we will do reverse, from ketone we have to get 2 degree alcohol. So what we will do? If we will do the ketone and we will do the reduction, we will get ketone. Okay, 1 degree alcohol with oxidation, we are getting aldehyde. So ulta process, opposite process is what? From aldehyde to 1 degree alcohol means what? Aldehyde, oxidation process happen. Reverse is reduction. From 1 degree alcohol, reduction will happen, we will get the aldehyde. So same, 2 degree alcohol, oxidation is ketone. Now reverse, ketone, reduction is 2 degree alcohol. Forward process oxidation, so reverse process is reduction. So aldehyde reduction is 1 degree alcohol, ketone reduction is 2 degree alcohol. Now Clemson reduction. Clemson, see, Clemson reduction and Wolff-Kishner reaction both are same. Means both are same, is just see here. Clemson reduction also will take the carbonyl group C double bond O connected with RR. Wolff-Kishner reaction is also, we will see that C double bond O connected with RR. Means what? Reactant are same. Clemson reduction, what is that? Carbonyl group connected with RR. C double bond O connected with RR. The same reactant for Clemson reduction, same reactant for Wolff-Kishner reaction. Okay. So now very important thing, Clemson reduction, we will take acid. Okay, it will happen what? In the presence of acid. Wolff-Kishner reaction in the presence of base. This is the difference. This is the difference. Now understand, Clemson reduction, Wolff-Kishner reaction. What is the reactant? C double bond O connected with RR. C double bond O connected with RR. The reactants are same for Clemson reduction also and for Wolff-Kishner reaction also. But what is the change? Clemson reaction will react in the presence of acid. Wolff-Kishner reaction reacts in the presence of base. So acid means ZNH and base NH2NH2. Okay. Now see the product. What we'll get here? CH2 connected with RR plus H2O. Here also CH2 connected with RR plus H2O. But we have NH. So we will get N2. Means sorry, we have N and N. For this N and N we will get N2. This is only the difference in Clemson reaction and Wolff-Kishner reaction. Clemson and Wolff, what? Both reactant are same. C double bond O connected with R and R. Clemson will go in the presence of acid with ZNH. Wolff will go in presence of base with NH2NH2. What the final product will get? CH2 connected with R plus H2O. Down also CH2 connected with RR plus H2O. And then we have a 2 nitrogen, so that's why we'll get N2. That's it. Okay. Now haloform reaction and aldol. Okay, see, haloform reaction means, understand the thing. Haloform reaction means C double bond O connected with R and then ethyl group. Okay, so C double bond O R connected with ethyl group. Sorry, methyl group. C double bond O connected with R connected with alkyl group only. So what will happen in presence of 2 NaOH with 2X2? So what will happen? R C double bond O and then it react with ONA. R C double bond O ONA plus this CHX3 plus NaX plus H2O. This is the reaction what you have to by heart. This haloform reaction. Before that, no need of by hearting Clemson reduction. So these are things. Okay. Chalo. Haloform reaction means what? C double bond O connected with R connected with CH3 group react with 2 NaOH 2x2. So what will happen? This CORCOONA will connect here, then CHX3 will connect here, plus NaX plus H2O. Okay, now aldol condensation, guys. Aldol condensation is very easy and very interesting and very important. Aldol condensation means either aldehyde and ketones having at least one alpha hydrogen, at least one alpha hydrogen. So one alpha hydrogen means what? See, we will see this carbonyl group. From carbonyl group, the next carbon will be, that's called alpha. So next with that's next you can see this here. There go. C double bond O. We will see the C double bond O. C double bond O. Okay. Beside of this carbon, the other carbon which is attached with this carbon, whatever the hydrogen is attached, that is called alpha hydrogen. Okay. Alpha means what? The first position. First position from where? This. Wherever the carbonyl group is there. Wherever the carbonyl group is there. From that, you see, wherever the carbonyl group is there, from that, the first carbon that is called as first position. First position means alpha, and with this carbon, whatever the hydrogen is attached, it's become alpha hydrogen, means hydrogen present at first position. From where the first position? Yes, we will see the carbonyl group. From carbonyl group we will see the first position of carbon, that is called alpha. Beta means, see, this is a carbonyl group. From here first position is alpha, second position is beta. Okay, so aldol condensation means aldehyde and ketones having at least one alpha hydrogen, at least one alpha hydrogen. It undergoes this reaction in presence of dilute alkali. These are the important points what I am underlining. So guys, aldol condensation means aldehyde also is possible, keton also it's possible. So either aldehyde and keton having at least one alpha hydrogen undergoes this reaction in presence of dilute alkali, and what we will get? We will get beta hydroxy group. Beta hydroxy group means at second, beta means what? Yes, second position we have a hydroxy group, means at second position we have OH group. So see here, this is what? Carbonyl group. So from here we will count. First position is alpha, second position is beta. At beta we have a carbonyl group, carboxy group. Okay, sorry, hydroxy group. So guys, hydroxy group means OH. Here also you can see the COH carbonyl group. First position alpha, second position beta. Here beta we have a OH group, hydroxy group. So this is what the final product we will get from here. Okay, so see what will happen here. Okay, so guys, all we know aldol condensation we had studied already. So aldol condensation means what we will do, whatever they had given CH3 C double bond OH, it reacts with same thing. See here also CH3 C double bond O CH3, it reacts with same thing, but only the little changes will happen. Understand? See, CH3 C double bond OH reacts with, we will take the first position. Okay, we will take the alpha position, and from here only we will break one hydrogen. What we will do, from here only we will remove one hydrogen. So CH3 means it will become CH2 and one hydrogen. The reason behind is we will break the hydrogen here. The hydrogen is what? H plus, and see what will happen, C double bond O. So oxygen is what? Oxygen is more electronegative, so this electron will go towards oxygen, it will become minus, carbon will become plus. So bhaiya, what will happen, we want to break this H, so that's why this H will go and connect with O minus, so H plus O minus, so that's why it will become OH. That's the reason we have, what we have to do, we have to write the first product as it is, first reactant as it is, CH3 C double bond OH, first reactant as it is, it's reacting with same, but what we will do, wherever the alpha position, from here we have to remove one hydrogen. Wherever the alpha position, from here we have to remove one hydrogen. Why we are removing one hydrogen? The reason is this H plus will react with here, this H plus will make a bond with O minus. So it will become OH, hydroxy group. Okay. So see, same here. What is the main reactant? CH3, C double bond O, CH3. So this is what? This is aldehyde. This is what? This is a ketone. So I am showing for both aldehyde as well as for ketone. So aldehyde, what will happen? CH3, C double bond O, H reacting with same. But what we will do? At alpha position we have to remove one hydrogen. So CH3 it will become CH2 and H, and then remaining it will remain same, C double bond O H. So here guys, what we will know that in the main reactant this oxygen is more electronegative, so it will take the electron from here, so it will become minus, it will become plus. And here what will happen? CH3 it will be a break like a CH2 and H. So what will happen? H will be plus, this will be minus. So this plus will connect with oxygen minus. So it will become single bond OH. And what will happen? This minus will connect with this carbon ka plus. To understand how we will write. So starting we will write with the main reactant. Main reactant is CH3C, CH3C, H is connected with, right? CH3CH. And what will happen? This is going to break into single bond. Single bond with O, H will attack. OH. CH3, CH, here OH. CH3, CH connected with OH. Now this plus is will get connected with this whole minus. So it connected with CH2, C double bond OH. Finish. Like this only you have to do. See for the keton. Main reactant is CH3, C double bond O, CH3. It react with its same, but what we will do? Take any one. This is also alpha position, this is also alpha position. Take any one. So I will take this alpha. So this alpha, what I have to do is remove one hydrogen. See here also we removed one hydrogen. The reason behind it, this is C double bond O. So oxygen is more electronegative. So this bond will break and it will go towards oxygen. The oxygen will become minus, carbon will become plus. And here when we will remove one hydrogen, hydrogen is H plus. So this will become minus. So what will happen? This H plus will attack O minus. So every time it will making OH, because we have to get the hydroxy group. At beta position. Okay. So that's why what will happen? See, CH3C. Okay, CH3C. C is connected with again CH3. So I will write down like this CH3. Okay, and then this single bond O minus connected with H plus. So single bond OH. And then what will happen? With this carbon plus whole this carbon minus will attach. So see there, then what will happen? This minus part, CH2, C double bond O, CH3. That's it. See, this is the main carbonyl group. With that first position alpha, second position beta, we have a hydroxy group. This carbonyl group, okay, first position alpha, second position beta, we have a hydroxy group. Khatam. This is a aldol condensation. And guys, what you will do is open the NCERT textbook. There easily they have mentioned the cross aldol condensation. To go and do the cross aldol condensation there. Okay, so cross aldol condensation means what will happen? You will be having two reactant. With that two reactant, again you have to make a two more. Means see here we have a one reactant. For that one reactant we are making one more, in which we are removing the hydrogen. Here also one reactant, we are making one more reactant. So what will happen in cross aldol? Cross aldol we have a two reactants like this. Suppose one reactant, another one reactant, two reactant. For each two reactant we have to make like this. Each two reactant we have to make like this. So sorry, for each reactant what we have to do? We have to make like this. This means what? From alpha position we have to remove one hydrogen. So that's why this H plus will connect with O minus. So it will get the OH group. Okay. So this is a cross aldol. So cross aldol means, guys, we have to just check it out. Cross aldol means we have a two reactant. For each two reactant we have to make the two more like this. For first we'll get like this. For second we'll get like this. Okay. So cross aldol we have to see one thing. If both the reactant is having at least one alpha hydrogen, then the total we will get is 4 product. If you want, I am dictating as you can write. In cross aldol reaction, what will happen? Again, cross aldol we can take for ketone also, we can take for aldehyde also. So what will happen? Here we have a two reactant. Here we have a two reactant. For each reactant, again we have to write like this. For first reactant, I am writing this. For second, another second reactant, you have to write like this. Okay. Second means what? This means what? This means what? From same reactant, we are removing one hydrogen and we are writing like that. Okay. So we have to just check it out. If both the reactant are having at least one alpha hydrogen, then the total number of product is 4. Okay. Now next point is, if at least any one reactant is having alpha hydrogen, then total number of product is 2. Remember this. Okay. Next we will see the Cannizzaro reaction. Cannizzaro reaction is the opposite of aldol condensation. Cannizzaro reaction opposite of aldol condensation. I hope you understand this part about the cross aldol condensation. Go open the NCERT textbook, keep this concept in your mind and this aldol condensation concept in your mind, and then go easily you can solve the cross aldol condensation. Okay. Next is what, guys, this we are reading about the chemical properties. 1 2 3 4 5 6, then we'll move on for 7. Cannizzaro reaction is nothing but opposite of aldol. Opposite of aldol means, see here what will happen? Aldehydes which do not have alpha hydrogen. Aldol, what we know? Aldol means aldehydes which have at least one alpha hydrogen, then only it will undergo aldol condensation. Okay, remember the thing, guys. Aldol condensation, when the aldol condensation will be possible, only in one case, either aldehyde or ketone, they must have at least one alpha hydrogen, then only the aldol condensation is possible. And in the product, what we will get the beta hydroxy group. Beta hydroxy group means at second position we will get the OH group. That is for aldol. Cross aldol, you get to know if both the two reactant will be there. For each reactant, again we have to write the similar reactant in which from alpha position we will remove one hydrogen. So with two reactant we will get the more two reactants. So 4 reactants. Okay, in cross aldol condensation. So cross aldol condensation, we have to see if both the reactant is having at least one alpha hydrogen, total number of product is 4. Out of both two, if at least one reactant is having alpha hydrogen, total product is 2. Okay, so Cannizzaro reaction is opposite, where we don't have alpha hydrogen. So see, aldehydes which do not have alpha hydrogen atom, what will happen? It undergoes disproportionation on heating with concentrated alkali. This is the Cannizzaro reaction is opposite of aldol reaction. Here we will say aldehydes which do not have alpha hydrogen. If they have alpha hydrogen, it will become aldol condensation. Okay, so opposite of aldol condensation means they do not have alpha hydrogen atom. So see aldehyde reacting with concentrated alkali. Guys, देखो aldol condensation, what we have taken? Aldol condensation we are taking dilute alkali, because and aldol condensation opposite is Cannizzaro. So Cannizzaro reaction we are taking concentrated alkali. Okay, concentrated alkali. So what we are going to get? We will get HCOONA plus CH3OH. Okay, we will get this thing. Because see here, what will happen? See this HCO. Okay, see how you will write C double bond O H. So HCO, and this again I will write HC double bond O H plus NaOH. So how it will react? Here देखो, it will react HCO we will take from here, and from here we will take is from here we will take is ONA. Okay, so HCO and then ONA will connect here. Then remaining is what? Remaining is CH. How many H? 1 2 3 H. So CH3 and then OH, this OH. Okay, CH3OH, like this Cannizzaro reaction. Next is preparation of carboxylic acid. Very simple thing, guys. Very simple thing. Dekho, we already studied this. 1 degree alcohol, if we will oxidize in presence of mild oxidizing agent, that is PCC, we will get aldehyde. Again aldehyde, we will oxidize in presence of mild oxidizing agent, we will get carboxylic acid. This is the one method. Okay, another is what, from 1 degree alcohol, if we will take the strong oxidizing agent, that is KMnO4 or K2Cr2O7, directly we will get carboxylic acid. This reaction already we studied in alcohol, phenols and ether chapter. Okay, 1 degree alcohol will oxidize in presence of mild oxidizing agent, we will get aldehyde. Same aldehyde we will do oxidize, means oxidation in presence of mild oxidizing agent, we will get carboxylic acid. But same 1 degree alcohol, if we will take the strong oxidizing agent, that KMnO4 or K2Cr2O7, directly we will get carboxylic acid. Now next is from alkyl benzene. From alkyl benzene, guys, understand one thing, very important thing and very easy concept I will tell you. From alkyl benzene, what will happen? See, this already we studied. From toluene we will get the, see guys, here, there, from toluene what we are getting, we are getting, see, from toluene we are getting benzaldehyde in presence of this. Same thing if we will do, same thing if I will do from toluene, if I will change this strong oxidizing agent, okay, see, this we know already, we studied in alcohol, phenols and ether. So this what we know from alkyl benzene, means from toluene. Okay, from toluene, if we will take the strong oxidizing agent in presence of H3O plus, we will get carboxylic acid. Next, from Grignard reagent, very simple, guys. Grignard reagent, I will take C double bond O, C double bond O. Guys, Grignard reagent, what we know? Yes, we know RMGX in presence of H3O plus. To Grignard reagent, what will happen? Guys, we know. See this O double bond C, the left hand side it will remain same. Now here what we have? We have a C double bond O. So it will break into two part. One part, what will happen, the O will be there, with O what will come? Yes, H will come, it will make OH, and here with C what? This R will get attached. So this is, and remaining is MgOHX will be our byproduct. So main product is this. Already we studied about the Grignard reagent, right? So what does the Grignard reagent do? Yes, Grignard reagent means the left side, the back portion will remain as it is. Front, what will happen here? C double bond O, the bond will break into single and single. So what will happen here? One single means O. Obviously we know with O minus, H plus will attack. So OH, one alcohol group we will get OH. And here what will? Another, this R, means any alkyl group will attach. So this is only the main process for Grignard reagent. With C double bond O, we will break that bond to C single O. So C single O means O minus. With O minus, always H will attack, OH group. Another C, what we will do? One alkyl group will attack, Cr. This alkyl group, not another. This alkyl group will attack. Okay. Now from nitriles. From nitrile means what? C triple bond N, C triple bond N in presence of H3O plus. So what will happen? This bond will break. It will become C double bond O, and one means OH. C double bond O, OH. That's it from nitriles. This is a what? COH. Okay. Now chemical properties of carboxylic acid. Chemical properties of carboxylic acid. First is decarboxylation reaction. Decarboxylation means, D means removal of carboxyl group. Removal of carboxylation means carboxyl group here, or you can say carbon dioxide. Removal of carbon dioxide. Removal of carbon dioxide means, see this CO2. What is this? CO2. Removal of carbon dioxide. So bhaiya dekho what will happen. R is connected with COONA plus NaOH in presence of CaO. So what will happen? We have to remove this only, C double bond O. Okay, C means CO2. So what will happen? R will connected with H. RH alkane we will get, and remaining is Na. So Na2CO3. Na2CO3. Okay. Next is very important, guys. Very important. HVZ reaction. HVZ reaction. Very important. HVZ reaction. Here we will take RCH2COH, means carboxylic acid. RCH2COH carboxylic acid in presence of X2, react with X2 in presence of red phosphorus. So react with X2 means, again I told guys, chlorine and bromine. The reason behind fluorine and iodine I will not take, I had explained you. Okay. So HYZ reaction, very important. Here we will take the carboxylic acid, means RCH2COH reacts with X2 in presence of red phosphorus. So what will happen? This X will attack the alpha position. This X will attack the alpha position. Alpha position means what? देखो प्यारे, RCH2, अरे ओ भैया देखो ना, C double bond O, OH, right? So see this C double bond O, this is the carbonyl group. So what is the alpha position? This is the alpha position. This is the correct answer, guys. This is the alpha position. With alpha position, what will happen? The X will attack. X will attach to the alpha positions here. Khatam. HVZ reaction, what will take? We'll take the compound of carboxylic acid. Carboxylic acid, which compound? Where we have a alpha hydrogen. Where we have a alpha hydrogen. Why? The reason behind is that carboxylic acid compound will react with X2 in presence of red phosphorus. So this X will attack the alpha position. So see this. Khatam. Now next is what? Next is this is very important. Yeah, important because see, after that you don't have anything. Distinguish to distinguish, iodoform test, fillings, solution test, Tollens reagent test. That's it. Khatam. So this is the important, guys. Understand. Now see, carboxylic acid group. Carboxylic acid group. So you have to remember that it's reacting with what? Okay. So carboxylic acid group COOH. Carboxylic acid group react with ROH with H plus. So what will happen? See, this OH group will get separate, and here R dash will attack. Sorry guys, wait. Sorry, here OH group will get separate with this H. What it will become? It will become H2O. Okay, H2O, and then what will happen? This R dash will attach to O. So see again, once again, carboxylic acid group we will take. Carboxylic acid group will take RCOOH. So what will happen? If it is reacting, every time it will be the reactant is carboxylic acid group only. Now what the thing is, we have to see the reagent. Okay. So if it is carboxylic acid group and reacting with this R dash OH in presence of H plus, R dash OH. So what will happen? This OH and this H will get separate and they will make H2O, and then remaining R dash will attach with O. So it will become RC double bond O OR dash. Okay. So this plus H2O, this process is called as esterification, because this is what? This is ester. The process of formation of ester is called esterification. So how will get the esterification? From carboxylic acid group, it will react in presence of R dash OH with H plus. So this OH which is connected with R dash, that OH, and here H will get separate and it will produce H2O, and then this R dash will connect here with O. It will become R C double bond O O R dash, ester. Now next, understand very simple thing. If carboxylic acid group react with either PCl5, PCl3 or here NH3, nothing will happen, guys. Simple thing. This end, this is the end. Yes, this end will break. Oh bhaiya, this end will break, and here whatever the group is there, na, that group will attach. Simple. Khatam, khalas. See there, carboxylic acid is reacting with PCl5 or PCl3. What is the group here? Chlorine. What is the group here? Chlorine. So OH will break, the OH group will break, and the chlorine will attach. See here, RC double bond O Cl. Every time the OH group will break with So OH group will break to form H2O. Okay, see RC double bond O, OH react with PCl5 PCl3. What is this group? Cl. What is this group? Cl. This chlorine group will attack here and OH group will break. The reason behind is it will break OH and this H plus. Here it will be everywhere H plus. H plus. This OH group will break, so it will be OH minus H plus, it will make water. OH minus H plus, it will make water. So here OH will remove, so what will attack? This which group? Chlorine. The chlorine will attack. Here which group? NH3 means NH2 group. Are oh pyare, NH2 group will attack. Khatam. So carboxylic acid OH will remove whatever the group, it will attack. PCl5 or PCl3, chlorine will attack. NH3, NH2 will attack. Okay, HNO3, NO2 will attack. So that is the process. Khatam. And very important thing, carboxylic acid COH is deactivating group and it is a meta directing. See guys, please understand one thing. If you know, you know, and you should have to know. See, this is what? This is a benzene group, aryl group. This is what? This is a benzene group, aryl group. We studied before already. When aryl group is there, and anything attached with aryl group like Br2 or concentrated HNO3 with concentrated H2SO4, what will happen? What will happen? Yes, with this aryl group, if Br2 or concentrated HNO3, concentrated H2SO4, if they will be the reagent, what will happen? Same aryl group will be there. The reagent will go at ortho position and then another product is reagent will go at para position. The ortho position and para position. The ortho position will become the minor product and yes, para position will become the major product. You know, right? If you don't know, please go and see the haloalkanes and haloarine chapter. Okay. So what we know? See, alkyl group, why this point is very important for you to understand, because already we studied that if we have a aryl group, means benzene group, and if you will take the Br2 or if you will take the concentrated HNO3 with concentrated H2SO4, what will happen? The reagent which will break from there, one it will attach at ortho position, another will attach at para position. The para position will be our major product, ortho position will be our minor product. Okay, but if we have a aryl group only, but it is attached with carboxylic acid, only this changes, because carboxylic acid is deactivating and it is meta directing, because there we have seen it is ortho and para directing. Here carboxylic acid is a meta directing, means if I will take the benzene attached with COOH only in this condition, oh pyare, not don't do with any other, only aryl group, the benzene attached with COH, aryl group, the benzene attached with COH, and it will go under any. If concentrated HNO3 with concentrated H2SO4, so HNO3 means which group will come? We all know that NO2 group, so it will connect at the meta position because it is a meta directing, meta position only NO2. Here aryl group, but it is connected with COH, COH, carboxylic acid, reacting Br2. So what will happen? It is a meta directing. At meta position, we have a bromine, the major product. That's it. Khatam. So this thing you have to remember, very important. So aryl group, if not COH is there, then one will go at ortho position, one will go at para position. Okay, para will be the major product, ortho will be the minor product. But same aryl group means benzene, if we have a COH, carboxylic acid, then it will be a meta directing. It will go and connect at the meta position. Okay. Now test to distinguish. If we are doing iodoform test, so iodoform test means what we will, final product we have to get CHI3, which is in the yellow color. Then only we will say that iodo test means positive. Okay, if you will not get the CHI3 in a yellow color, then iodo test is negative. If you will get the CHI3 in a yellow color, iodo test is positive. And this is the reaction. You have to remember the reaction. C double bond O are connected with CH3, reacting with 2I2 plus 2NaOH will get the CHI3 plus RCONA plus H2O plus NaI. Okay, So CHI3, if we will get in a product, any reactant is given, if we will get in a product is CHI3 yellow color, then we can say the iodo test is positive, means it shows the iodo test. Otherwise iodo test is negative, means it will not show the iodoform test. Okay, done. If they will ask you to write the iodoform test reaction, then you have to write down this reaction. Okay, next is filling solution. Guys, filling solution and Tollens reagent, both tests are same. Understand one thing, fillings test and Tollens test, both is a mild oxidizing agent. Remember one thing, guys, very important guys. See, fillings reagent, that test, and Tollens, this test, both are mild oxidizing agent, both are mild oxidizing agent. But रुको जरा सब्र करो. See here, fillings test and Tollens test, both is what, both are mild oxidizing agent. Mild oxidizing agent means both will show the positive result only in presence of aldehyde. If we will take the ketone, it will show the negative result. Negative result means filling test and Tollens test is not possible in ketone, it is only possible in aldehyde. Why? The reason behind is the both are mild oxidizing agent. Okay, Felling's reagent and Tollens test, filling solution and Tollens reagent, filling solution and Tollens reagent, both are what, both are mild oxidizing agent, both are mild oxidizing agent. So that's why both will show the positive test only for aldehyde. For ketone it will not show the test. For positive it will show the test, for ketone it will not show any test. Okay, so Felling test and Tollens test, if you will compare this Felling solution and Tollens reagent, both are mild oxidizing agent, both are mild oxidizing agent, but in this both, which is stronger? Tollens reagent is stronger oxidizing agent. This both are mild oxidizing agent, but in this both, if you will compare, Tollens reagent is a stronger oxidizing agent. So that's why Tollens reagent is a stronger oxidizing agent. So that's why Tollens reagent will oxidize the aliphatic aldehyde also, and it will oxidize the aromatic aldehyde also. The reason behind, because it is a stronger oxidizing agent as compared to Felling's reagent, Felling solution. Okay. Now Felling solution is a less oxidizing agent as compared to Tollens, so it will oxidize only aliphatic aldehyde. Okay, wait a moment guys. Okay, yeah, so see here. Sorry, I went for closing it. Outside the noise will come. Okay, guys, once again, Felling solution and Tollens reagent, both are mild oxidizing agent. So that's why both will show the positive result for aldehyde, means both will show the result for aldehyde, they will not show the result for ketone. And if you will compare in the Felling solution and Tollens reagent, Felling solution and Tollens reagent, Tollens reagent is more stronger oxidizing agent as compared to Felling's solution. So that's why Tollens reagent will oxidize the aliphatic aldehyde also, and it will oxidize the aromatic aldehyde also. And but the Felling's solution will oxidize only aliphatic aldehyde. Okay, so this is the reactant. So Felling solution test, how you will get to know? If we will get the Cu2O in the product with a reddish brown color, then it will show the positive result for Felling solution test. If you will not get the Cu2O reddish brown color, no, it will show the negative. Okay, this is the reaction, guys. You have to remember the reaction for both. Felling's test reaction is this, and Tollens test reaction is this. Okay, just I will tell you how you will get to know. If in the product we will get if in the product if we will get CHI3 in yellow color, we will say that iodoform test is positive, means it shows the iodoform test. If in the product we will get Cu2O reddish brown, Cu2O reddish brown color, then we will say the Felling solution test is positive, and this is the reaction for Felling's solution test. Tollens reagent test, if in the product we will get the Ag, means silver precipitate. In the product if we will get the Ag, means silver precipitate, then only we will say the Tollens reagent test is positive. And this is the reaction for the Tollens test reagent. We have to remember the reaction. Okay, yeah, this is the done guys, what I have told you. So we had completed the 3 chapters of organic chemistry: haloalkanes and haloarenes, aldehyde, ketones and carboxylic acid, alcohol, phenols and ethers. So next video we are coming up with amines. If you are liking the video guys, please share with your friends, let them will also get benefit. Okay, this video went to 1 hour. Yeah, because this is, you know, it's a bit lengthy chapter as compared to other 2 chapters. So fine, because amines and molecules it will be on almost same 40 to 45 minutes of the chapter. Okay, because this chapter is very lengthy. Amines and biomolecule is not that much, both will consist of, you know, 40 to 45 minutes it will get over. Okay guys, if you like it, please share with your friends, subscribe my channel and like it. Like, okay guys, thank you, bye bye, we'll meet in the next video.